So I'm not still using the neural network to move the AI agent, but I finished implementing the backpropagation part for the neural network, but I just haven't integrated it into this 3D world. But I thought it would be a good point to make a video, so I decided to make this video. So like previous video, I really didn't touch on the graphics side, but as you can see, I changed the window so that it would be a full screen mode, so I can observe more easily. So this is pretty much it for the graphics side. So in the previous video, the main function looked like this. Now for the alloc console function, I'm passing this macro so that rather than me making new console to debug, I can use this console for debugging. It's pretty convenient, and this policy actually returns an action, so I properly take the action, then pass it to the step function from the environment class. But as you can see, I'm not using the action, and so this is the reason I haven't integrated it into the virtual world, that I'm not really understanding how to use this. And yeah, it's almost there, but then things to learn a bit more. And I created a class called replay buffer, which would store these states: state, action, reward, next state, done. The reason I'm doing is that I'm not planning to train the model every frame. Rather, I set the condition that I only train the model whenever size of the replay buffer is greater than the batch size, and the frame count, which would be incremented in every frame, is multiple of train interval, which is set to 4 for now, so that I wouldn't, so with this I wouldn't train the model every frame, which is I think uncommon. So inside this function, I take random samples of this old batch size, and I extract each things, because this sample function returns this type, which is a tuple, vector tuple of tensor size t float tensor bool. So I need to extract each values and convert into tensors. And this seems like a function from std vector, but I don't know why I hadn't done this, but I created pushback for the tensor class so that I don't need to, with this I could just before I used to, whenever I needed to assign values, I needed to create a tensor, but I also needed to indicate this shape for the tensor, otherwise it wouldn't work. But now I created this function, I don't need to specify shape for the tensor, and I just assign or add values, and it's really convenient. I got two networks, Q and target. Target act as like Y or label generator in typical deep learning or machine learning tasks, whether it's classification or whatever. You would prepare data set X and Y, but for this task, for this project, I don't have the data set, so I need to create data set. So I think this is the reason I need to have this target network, which act as a Y dataset generator, and this target would be trained less frequently than Q network, and the reason seems like because if you train target network as often as Q network, which means you're changing the Y or labels too frequently, which would lead to unstable model. I'm not really sure, but yeah. So if the frame count is multiple of target update interval, I think I assign weights and biases for a Q network to weights and biases for the target. So each networks have individual parameters, and in some interval I assign. So it's pretty much the target network is a copy of Q network, and it's delayed network. I'm sorry, I think I'm not really perfectly understanding, but I'm just thinking this would just, generate Y values. So, yeah, so this would compute the Q values and predicted Q values, and I pass it to the loss function and also to the backward function. And let me show you how I implemented the backward. It's just plain old traditional backward. Like I've been always saying in my videos that in PyTorch or TensorFlow, they would create things known as graph, like a computational graph, but and which would be used to compute gradients. Inside this graph, you can see how forward function was computed. Like in my case, computational graph would be like this, and the old grad would see this graph and automatically take gradients, but for mine, I'm manually taking gradients, and yeah, and this is where I update the parameters. I'm not using Atom Optimizer. In my previous project, I used to use Atom Optimizer for recurrent neural network. So this would be the atom optimizer. But yeah, I think I'm not sure. For now, I just go for plain old. I think it's called stochastic gradient descent type optimizer. Yeah, and also I have this update epsilon. So as the training goes on, the epsilon gets smaller by multiplying by this epsilon decay, which is really small number, I guess. It's not that small, but when you multiply by a value less than 0, the number gets multiplied would definitely get smaller. So and the reason we do that is that as the epsilon gets smaller, the agent wouldn't choose a random action, but rather choose the action with the highest Q value, which would be, I guess, more precise than choosing random action, because in this case the AI is understanding which action would be more appropriate, I guess, than, because as like the human wouldn't randomly take action. They think and decide which would be the most optimal action to take within the current state. So but these are more these are things I need to learn and study more to understand. And yeah, so yeah, I pretty much prepared to this circumstance where I now only need to integrate this into this meshes. So by the way, this white cube is the agent. So the only thing I need to do is just integrate this neural network to this cube, or just integrate this into graphics API and so on. So I just wanted to inform you guys that I finished implementing the backprop part and and the main loop, I guess. I think this would be the fundamental things, and later I'm planning to use. So I'm currently using DeepQ neural network, and it seems like there are more advanced one. They've double DeepQ learning and maybe other as well. But yeah, for now I'll just experiment with DQN. So I guess this is it for today's video, and thanks for sticking to the end of the video, and maybe by the next video I will be finishing integrating, unifying all the stuff, and maybe more fun part. Okay, thanks.